With this video, we're going to look at forces acting on objects and finding the resultant force. Alright, now all forces can be broken down into their component parts, and that means the component of each in each of the directions I, j and k. Okay, now for this two-dimensional example in front of us here, we only have to think of the components of I and j. But if we can express a vector in its a force acting on an object in vector form, then we will have it in each of its components. So for instance, if we have a force here that's 6 newtons making an angle of 45 degrees with a horizontal, then we can write that force F1. That's the first force acting on some object at the origin here. It's pulling to the right and up. Okay, and we're taking those directions as plus x, plus y. Okay, this is negative x and down here negative y. So F1 will be 6 cos 45 degrees in the I direction plus 6 sine 45 degrees in the j direction. Okay, second force over here. This force of 5 newtons makes an angle of 150 degrees with the positive direction of the x-axis. And that's the axis from which we define all our angles. So F2 will be 5 cos 150 degrees in the I direction plus 5 sine 150 degrees in the j direction. Now, by the symmetry properties, you could write that as minus 5 cos of 30 degrees. Okay, because cos of 30 degrees would be out this way. It would be a positive value, whereas this would be the negative of it, 150 degrees, because you can see that angle in there as being 30 degrees there. Okay, 180 minus 150 is 30 degrees there, and by the symmetry properties, that distance there would then be equal to some, if this were 30 degrees here, that's the related first quadrant angle. And so from the symmetry properties, you could say this is minus 5 cos of 30 degrees, because 5 cos of 30 degrees would be this here, okay? Minus, because we're going in the negative x direction over here, so we'd simply put a minus in front of it. This, similarly, this is in the positive y direction just as this is, and so we could write those 5 sine 30 degrees. Okay, so we can make use of those exact trigonometric ratios. Okay, so what do we have? The resultant force here, that's the total force acting, is F1 plus F2, and it's as simple as just combining the coefficients in the I direction and combining the coefficients, that's just adding the coefficients in the j direction, and so we have 6 cos 45 degrees plus 5 cos 150 degrees in the I direction, plus 6 sine 45 degrees plus 5 sine 150 degrees in the j direction. And if you put that through a calculator, you'll get these values here. Cos of 45 is 1 on root 2 times 6 on root 2. 5 cos 150 degrees will give you root 3 on 2, because, as I pointed out earlier, that cos 150 degrees is the same as cos 30 degrees in this direction, and then negative, because we've got to go this way. This length here, same as this length here, but this is just in the negative direction. This is in the positive direction. So put a minus there. And we would then have cos of 30 degrees, which will give us square root 3 on 2, and times the 5 out front. Here, sine 45, well, sine 45 is 1 on root 2 times the 6 again. Sine of 30 degrees here, that's going to be this distance here, times 5, sorry. That's that distance there. Now they're both in the positive direction, so they're both the same value. So sine 30 degrees is the same as sine 150 degrees. Okay, sine 30 degrees is of course a half, times 5 out front, so we have 5 on 2. Putting all this through a calculator, so the total resultant force is approximately negative 0.087486 times I in the I direction, and plus 6.74264 approximately in the j direction. Now, the magnitude of all this, the magnitude of the resultant vector, all right, how many newtons, will be the square root of the square of each of the components added together, and then the square root of the total. So it's the sum of the squares of the components, then the square root of that. So we get 6.74321 newtons. What direction does it make? All right, what direction this is making? Well, you can see there's some in the negative direction here, and mostly a lot of it in the positive vertical direction. So it's going up and to the left a bit. What angle is it making? Okay, well, it's making tan theta is this value over this one is 77.0711 degrees. Okay, inverse tan, my apologies, is not degrees at all. This divided by that is this. Okay, theta is inverse tan of that is 89.2566 degrees. Notice I haven't put the minus here because there's a minus here. Notice there's no minus. Okay, tan is negative in the second quadrant. Okay, so our solution will lie in the second quadrant, but before we do that, let's find out the related first quadrant angle. So we simply take the positive values, divide them. That gives us 77.0711. Inverse tan of that gives us 89.2566 degrees. Okay, but that is not the solution. All we've done is found the related first quadrant angle. To find the solution, we need 180 degrees minus that angle. Okay, so this angle goes in here. The solution lies in the second quadrant. We can see it's in the second quadrant because the x component, the horizontal component, is negative, and the vertical component is positive, so that puts us in the second quadrant. We know that tan is negative there. And so the solution is 180 degrees minus theta, this theta here, the related first quadrant angle. So 180 minus that gives us 90.7434 degrees. So our solution will be, if we plot it like that, is just a little bit past the vertical there. Okay, making a total angle here of 90.7434 degrees, just a little bit over the vertical. Okay, that's that.